Hefei addressed the challenge of long-distance displacement measurements using optical fibers. The technique can be used in both basic research and industrial production. With the right setup, arbitrary displacement can be measured. Other methods are limited by the strength of the optical fiber.
This methodology is appropriate for use in industrial settings. The user just needs to put the magnetic scale on guide rail. This method could provide insight into the research area of optical fiber sensing. It can be used to measure other parameters such as velocity and acceleration.
Create the fiber Bragg gratings with the scanning phase mask technique. For this, use single-mode optical fibers that have been in a hydrogen-loaded airtight container for 1 week. The phase mask technique involves focusing a laser beam through a phase mask onto an optical fiber to create periodic modulation of its refractive index. Once 2 fibers are inscribed, place them in a 100°C oven for 48 hours to remove any residual hydrogen. The retrieved fiber gratings parameters will no longer change after the annealing step. Implement the design of the magnetic scale with the appropriate magnets. The scale has slots to hold a set of cylindrical magnets along its length. The north and south poles of the permanent magnets alternate along the scale with a 10 mm pitch. The magnets in this study are 5 mm in diameter and have a magnetization of 750 kA per meter. 2 detectors set at a fixed distance apart will feel different forces as they move along the scale.